Probability example 24. Now on A through D, all of these are going to be combination problems. So hopefully you will notice on each and every problem why order would not matter in that particular situation. Like on A, it talks about planning a party committee. There's nothing important about the party committee positions. So there's no committee member number 1, number 2, and so on. So order would not matter there. On B, you're being dealt 5 cards from a standard deck. When you're being dealt cards, usually, the order doesn't really matter. A hand is a hand. Okay, that's the case with B and C. And on D, you're being given tickets to a concert. Now, in this case, we're just talking about whether or not people are given the concerts. We're not the tickets to the concert. We're not seating them at the concert at this particular time. So at this point, it's just whether or not you have the tickets. Okay, so let's begin. There are 14 staff and 10 managers at a company. 5 people are needed to plan a holiday party. And how many ways can a party committee be made up of 2 staff and 3 managers? Now that and is going to be pretty important for us. Remember that and generally meant to multiply. So as far as the staff, we have 14 staff. We need how many of them? We need 2. And then on the managers, we have 10 managers, and we need 3 of them, okay? So again, order did not matter. We just have committees here. So I have 14 choices for the staff of size 2, and I have 10 choices of the managers, and the size would be 3. So 14C2 times 10C3 yields 10,920 ways that can happen. B, you are dealt 5 cards from a standard deck. How many different hands consist of 3 hearts and 2 clubs? Alright, so we have, how many hearts in a deck of cards? We have 13 hearts. We need 3 of those, and we have also 13 clubs, and we need 2. Okay, so we are dealt 5 cards. That handles just about everything. So we have choice of 13 to choose from, and we only need the size of 3. That's the hearts. And for the clubs, we have a choice of 13 different clubs, and we only need 2 of them. And that will give us 22,308. Please notice the difference between B and C, where C, again, we are dealt the 5 cards from the standard deck, same thing. How many different hands consist of 3 hearts, and then it stops? Well, we need 2 other cards, don't we? Because it is a hand of 5 cards, so we're going to have to account for the 2 others. So note how we do that. We're going to begin the same, where we have 13 hearts, and we need 3. And we need 2 other cards. We are choosing from all other cards in the deck. So we have 39. I'm going to call them other. And we need 2. Okay? So we have 13C3 and this case 39C2. So this one has exactly 3 hearts, 2 clubs. This has 3 hearts and 2 anything else. So that will give us, and we should expect a higher number here, shouldn't we? 211,926. A local printing business is one of the sponsors for a community concert. As a thank you for their sponsorship, the business is given 4 tickets to the concert, so that's all they're giving out. The business invites any employee who would like to go to the concert to submit their name, and 4 winners will be chosen at random. 17 people submit their names. Bert and Ernie among the hopeful concert goers. In how many ways can both Bert and Ernie be selected to win the tickets? So in this case, of those 4 tickets, we want 2 to go to Bert and Ernie, and then the remaining 2 can go to the rest of the people. All right, so I have 2 of the Bert and Ernies, and I need both of them. Okay? And I have, well, how many other people do we have? 15 other people. We'll call them others. And I need 2 of them. Do we have all 4 tickets accounted for? Yep, 2 and 2, that's 4. So that would be 2C2. Okay, remember we expect that to be 1. And then times 15C2. And that gives us 105. Now you have a worksheet, number 3, homework number 3, and that is a mixed worksheet of all the different ways that particular events can happen. So this would be very important for you to complete this worksheet before we go on to probability using permutations and combinations.